We reached the fourth video of our TP-Link router analysis tutorial. In the last video, we successfully dumped the firmware from the flash memory. In this video, we will focus on extracting the main component from the firmware, such as the bootloader, the kernel, and the file system for further analysis. So let's get started. When we run binwalk on our extracted firmware, binwalk identifies several segments within the firmware. We are mainly interested in the U-boot, this is the bootloader, the Lisma compressed data as it contains the kernel, and of course the file system. If we run binwalk with the -E, here binwalk calculate the entropy of our firmware. Usually calculating the entropy helps us to determine how compressed or encrypted the data is. Usually high entropy suggests that the data is likely encrypted or compressed, while low entropy indicates the data is probably not compressed or encrypted. Here in our case, we see we have two partitions where the entropy is high, it's close to 1. The first one here, which is likely represent the Lisma compressed data, and the second one here, which represents the file system. We will see that later. Now, even though, let's maybe stop this one, even though the binwalk identified several headers. However, in our first video, when we connected to the UART and read the boot logs, we saw there that the boot log shows more details information about the structure of the firmware. As you can see here, we have 7 different partitions. Doing simple calculation, we can get the start, the end addresses, and the links of each partition here. Why we are doing that? We are doing this because we need to use the dd command to extract these partitions. The general structure of dd command is it accepts a file, if input file. Here in our case it will be our extracted firmware, then output file, that's the name which is will be the same as the partition's name. You can give any name you want. Block size, we will keep it as 1 for simplicity. That means we move 1 block at a time. Skip represent the start address of the partition. I'm using the $sign and 2 parentheses because I'm supplying the data in hexadecimal. If you want to use only decimal, then you can remove them. Count represent the length of the partition. So to perform this process, I have written a simple shell script exactly doing what I explained. Here we have the input file. For each partition, I have the start and the links of the partition. Here a simple function called extract partition, which calls the dd command with the parameters we mentioned. And finally here, it will call this function to extract all these partitions. So once I go to the terminal, let's run this script. It will take some time, but you will see at the end it will give us the partition with the exact name as we have seen in the boot logs. So a few seconds. Okay, now we got them exactly. Here we have all our files. So let's start one by one. Maybe first we start with the boot. We run binwalk on the boot. As you can see here, it's identifying only one segment here, which is the U-boot. And if we run binwalk with the -E, you can see this is not encrypted or compressed data. So that's for the U-boot. Of course, you can use here strings command against U-boot. String command, it represents all the strings included in this binary. -n specify the minimum length of this string. Usually by default is 4. I'm using here 6, but you can use whatever you like. And as you see now, we can read all the strings inside the U-boot here in this case. Okay, our next step is we will do the same, but now for the kernel. So if we run binwalk on the kernel, again you would see it's determined as a lisma, so that means it's a compressed data. And if we again with the capital E, we should see here it's compressed. And at the end there is a drop to 0, because maybe at the end it's empty, there is nothing there. We can use binwalk again. It will help us to extract this compressed data. So in this time we run a binwalk, but small e here, extract. What happens now that binwalk provided a new directory. So if we jump to this new directory here, you see that we have two files. The first one, this is the compressed data, and then after that binwalk uncompressed this data. So now when we run binwalk on this 200, you would see much more header. Yeah, exactly. Now we have BGP keys, and most importantly we have here Linux kernel version 2.6.36. That's confirmed also what we have seen in aerial videos, the Linux kernel version. Just for simplicity, I will rename it from move from 200 to, I will call it TB link and data. This is the pin. One other, yeah, as you've seen here, all the information we have seen before. I want to mention one other thing about the kernel and the U-boot, especially here the GPL license. GPL stands for General Public License. That means when a manufacturer uses a GPL license, that means the source code should be available. Here in our case, we have a link to the TP-Link router, so let's go there. As you can see here that I have, this is our router. You see here I have the firmware, this is the update, even the app, and here under the GPL code we have all the code. So when I click here to download, it will ask me to if where I want to download it. I already downloaded here. So what that's mean now, that's mean once we downloaded the code, we can go there and we have everything, because it's now available. It must be available to us. You can see here I have the Linux kernel, you can see I have the U-boot here. So this is change your analysis from black box analysis to white box analysis, because you have the code, you have everything there, so you don't need to. So if I go here, I have it in the A5. So if I, as you see, if I run 3 and directly, maybe let's take level 2, I think I need -D. So as I mentioned before, we have everything. There is the U-boot, there is the Linux, the wireless. So all the information you want for further analysis, you will find it here as an open source code. That's what I want to mention about the kernel, the GPL. Now let's go to our next partition, which is the file system. Again, if I run binwalk on the root file system, you see now it's a Squash file system, Little Indian version 4, and if I run it with dash capital E, we expect a compressed data here. As you can see at the end it's fall to 0. Now what we want to do with this with the file system, we need to extract them, but we need to extract it in a correct way, and in order to do that we will use the fake root. So fake root, if you are not familiar, it's a command in the Linux. Dash S, I want to save my environment, so I will store it here, environment data, and I will use unsquash file system to unsquash those file system. Then I will specify a directory, let's call it squash file system, and then we need our root file system. Okay, so once I run it, you see here now I have a new file called squash file system. Why I'm using this fake root? So for example, let's go inside the squash file system. You see now this is a typical Linux file system. If I want to list the div, this is actually not correct. You see the user here, you see this is recognized as a file, not a device. However, let's go back. Because I used fake root, what I can do, actually I can say fake root, and then I provide the data I saved before, and of course I need the bash. So I do that. Now it's changed, you see now as a kind of root in the partition. So let's go again inside squash file system. We are inside, and let's the div here. You see it's different now. It's deal with the devices here as okay, the root, and here it's recognized as a character device or whatever, but now it's the correct way how to extract the root file system. And of course now you have the file system here as we seen. Yeah, of course you start looking for low-hanging fruit. For example, you can always look on the cat etc password. Here they have kind of backup there. There is to user. This is actually the same user when the first video when you connected to the GUI of the router there. However, here your analysis start. You can look on the inside the web again, inside the etc, all the third party binaries, all of this you can have a look and you can start analyzing there. Okay, let's exit from fake root file system. We go back to our final partitions. Here we have the config. Actually, when I run it, it's mostly it's random data. That might be kind of the default configuration of the router. So binwalk, let's run it on the config. So yeah, it's here, and if I run maybe the xxd, binwalk doesn't recognize anything, but I can run it in the xxd config, and yeah, I would see empty here at the end. There is some random data here, so that's why it might be related to the router configuration. Not much happening here. And the second one in the radio, it was also like mostly empty there. We can have a look also XD, but now on the radio, you see it's mostly empty there. And next one, it's I see here, okay, there are some strings on the radio, but nothing useful. And the final one is the ROM. The ROM is completely empty. Maybe this is used for later for update. Then we have a ROM file. Was interesting when I run the strings on the ROM file. I got 2 or 3 strings there. However, when I run the first one in hash identifier, said that might be SHA-1, and the next one also, when I run it, it said it might be MD5 or domain cache credential. So this is a suggestion. It looks like a hash. The first run, when I run it against a hash cap, it didn't break the hash. So that's also maybe further analysis needed there. But this is the only 2 information I got it from what they call the ROM file. I don't know what is the idea, what is the usage for it. So this also could be for further analysis. So at the end of the video, we learned how to extract the main component within the firmware. Here always you will find bootloader, kind of operating system, and of course the file system. Here we learned about the GPL license, which simplifies your life. Instead of black box testing to white box testing there. And of course, once you get the file system, you can go there, check for the binaries there, any third-party binaries, any binary written by the manufacturer themselves. This is would be interesting part, especially if you want to search for zero-day vulnerabilities. And of course, then IDA or Ghidra is your friend. This is part of reverse engineering. It's not included in this series, but in the future I might do something about reverse engineering. But for now, this is how we extracted the main component from the firmware. Thank you for watching, and see you in the next video. Bye bye.